Hello. If you're watching this, you should have just finished reading Making Measurements in Science. And so we're just going to take a few minutes to walk through that and point out some of the most important things that were in this reading so you understand what's going on. All right? So when we make any measurement in science, there's always three things that we want to know about that measurement. Okay, so the very first thing we need to know is we need to know what numbers to write down. So if I'm looking at a scale, should I write down 1.84 centimeters or 1.82 centimeters? Which is better? We need to know how many digits to include. Okay, so should I include two numbers after the decimal or only one number after the decimal? And last but not least, what units to use. Am I measuring in centimeters or am I measuring in meters? To make a successful measurement, I have to have all three of those things correct. I have to have the right numbers, the right number of digits, and the right units. So in order to do this well, probably the first thing I need to understand, and the thing that we're going to be focusing on today, is what are the scale and units of the tool we are measuring with. So whenever we have a tool that has a scale on it, what do I mean by a scale? I mean it has numbers like 1, 2, 3, 4, 5, 1, right? Okay. There are specific ways of measuring this that scientists have agreed upon. All right. So what we need to do is when we read a scale, we want to get all of the information from the scale that we can without getting more information than it's capable of giving. That amount of information is called the maximum capability of the measuring tool. We always want to measure to the maximum capability. So how do we do that? Well, let's begin by looking at this metric ruler here. Okay, what I always like to start with here is on making sure that people understand place value. All right, so as I roll through, imagine that I've got a number like 9876.2535. Okay, first thing I want to go through is just make sure we understand what each of those places are called. So if I start over here on the right, that 9 is in the thousands place. The 8 is in the hundreds. The 7 is in the tens. And the 6 is in the ones. On the other side of the decimal, I have this 2, which is in the tenths place. 5, which is in the hundredths place. The 3, which is in the thousandths place, and the 5, which is in the 10,000ths place. All right. Many of you probably know this instinctively just from from years of being in school, but if you don't know those place values and what they're called, you should. So make sure you understand what those different things are called along the way. So before I even start to take a measurement, I look at my tool. And what I want to see is on my tool, what are the units that we can measure down to? So if I look on this tool, I see that there are big lines here that are separated. Okay? And those go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that tells me that in the measurement I'm using with this ruler, I'm going to have at least something in the ones spot. Maybe something in the tens spot as well. Okay? But are there lines smaller than that? Yes, there are. There are these little lines right here, right? 10 more of them between the 4 and the 5 and between every other number. So if these bigger lines are in the ones spot, what's the next thing smaller than that? It's the 10th spot. So I know that my measurement is at least in the 10th spot. Now, our basic rule to measure something to its maximum capability of the tool is to go to the smallest divisions. So in this case, the tenths are the smallest division. And then what it tells us to do is estimate one more digit. So if I'm making a measurement with this ruler, I'm going to measure all the way out to the hundredth spot. This is going to be our estimate. And how do I do that? Well, I imagine that there's 10 more little lines between these small little lines, and I take a guess as to where in that space the object might fall. I'm taking a guess, so therefore it's an estimate. All right, so then in this particular case, we would say the general rule of reading a scale to its maximum capability is to read the scale down to the smallest division and then estimate one more digit. So let me show you in this one up here. We are going to be measuring using this ruler, and we'll measure to the end of this blue thing right here. Okay, so I go ahead and I look at this and I say, okay, so I want to figure out where I'm going to measure to begin with. So it's a ruler just like we saw on the other side. We've got big lines that go up in the 1 spot. Then we've got smaller lines than those, and the next place value smaller is going to be the 10th spot. I don't have any lines smaller than those, so I know I'm going to estimate in the 100th spot. All right, so how many of the 1's lines does this go past? Well, it goes out past the 4 line. So I'm going to put that in the 4 spot. Then I look, how many of the 10ths line does it go past? Well, after the 4, it goes past 1, 2, 3, 4, 5, 6, 7, 8 of those. So I'm going to put 8 tenths in that one. Then I come to my last one, okay? And this is where I'm going to estimate, okay? And for the estimation, what I do is I imagine that there are 10 more little lines between those 2 spots right there. And I estimate, the question I ask myself is it this object halfway between, more than halfway, or less than halfway? And if I'm looking at this and trying to be honest, my opinion on this is that it probably goes, and it's a little bit blurry, but it looks like it's maybe a little bit less than halfway, okay? So if it's less than halfway between the lines, I choose to either put a 2 or a 3 in that last spot. Okay, so my estimate is a 2 or a 3. Okay, if I think that this is halfway between, I estimate a 5. And if I think it's more than halfway, I estimate a 7 or an 8. Okay, why not 1s and 4s or 6s and 9s? Well, if you did the reading, you know that it said in there that because it's an estimate, if you estimate 7 or 8 or 2 or 3 in those spots, you're likely only going to be 1 or 2 digits off in your estimation. Whereas if you put a 1 or a 4 or a 6 or a 9, you could be 2 or more digits off in your estimation. And so that's just kind of the rule we follow. What happens if it's on the line? Well, if it's on the line, as we'll see in just a second, you're going to put a 0 in that spot. So if I'm measuring this particular example, I look in here and I go, oh, I think this is less than halfway, maybe just less than halfway. I'm going to estimate either a 2 or a 3. It looks to me like it's more towards the middle, so I'm going to go 4.83. Last thing I'm going to do is I'm going to go ahead and I'm going to put in my units of centimeters. Okay, so my measurement now has the right numbers, the right number of digits out to the 10th spot, and it has a unit. All right, so I said, what happens if it falls right on the line? We said we should put a 0 in that spot. And let me show you why that is important, okay? So if I measured this, somebody might be tempted to just say, oh, it's 3.2 centimeters, okay? But that's not really what we have here, because these go up in the 1 spot. These are smaller lines are in the 10th spot, which means we're going to estimate in the 100th spot. So I'm going to go ahead and I'm going to say 3.2, and then it looks like it's right on the line to me. And so since it's right on the line, I'm going to go ahead and I'm going to put a 0 there as 3.20 centimeters. Now, some people might look at those and say, oh, those are the same numbers. Yeah, they are the same numbers, but they tell us different information. By putting the 0 here, it's telling me and my readers that I used a ruler that has lines that are in the 10th spot. If I only put 3.2, that would mean that I'm telling you that I used a ruler that looked like this. 1, 2, 3, 4. Okay. That it doesn't have those little lines. It only has the ones in the one spot. Because if I were measuring using this, my smallest division would be my 3, and my estimate would be in the 10th place after that. So less than halfway, so I would use 3.2 centimeters. Okay. So the actual measurement is 3.20 centimeters with this ruler. If I used a different ruler with less divisions, I would say 3.2. That 0, again, is important for telling us which kind of scale was on our measuring instrument. One last piece that we have is many times we'll be using glassware and we'll be measuring liquids. And when you put liquid into glassware, sometimes you get a little curve inside that liquid or inside that glassware. And that curved line is called a meniscus. And it happens because water has cohesive and adhesive properties that cause it to stick to the sides of the walls a little bit. And what scientists have agreed is that we're going to go ahead and we're going to measure from the bottom of the curve. All right? So the graduated cylinder to the right over here measures in cubic centimeters. And so I'm going to look at this and I'm going to go, okay, this is 20. This is 30. So I'm going to go ahead and I'm going to say this is 20. These next lines are in the one spot, so I've got 2 of those. So 22, and then I get to estimate one more digit. And again, I'm not measuring where it is here, I'm measuring from the bottom of the meniscus, and that looks to me to be right on the line. So I would measure this as 22.0 centimeters. All right. So that's how you measure to the maximum capability of a tool. What I'd like you to do now, please, is go ahead and answer the questions that are on the next page of the handout. We'll start with question 1. It says, what is the length of objects A and B if they end at the arrows shown in the picture on the right? So maybe A is a little block that looks like this, and maybe B is a block that looks like that. Okay, so they want to know what is the length of those 2 objects using the scales that are here. Go ahead and give it a try and come back to this video when you're done answering those 2 questions. All right, let's do letter A. Okay, so letter A is in this part of the scale right here. In that part of the scale, my smallest lines are going up in the ones spot. There aren't any lines that are smaller than that, so I know that I'm going to have to estimate one more digit. So smallest line is in the one spot. I'm going to estimate in the 10th spot. Okay, this over here, so I look at this A, and I ask, how many of the ones does it go past? Well, it only goes past the 0, so I'm going to put that in the one spot. Then I look, and I look at this arrow here, and I see that it is less to me than halfway. So I'm going to likely put a 3 here. You might have also put a 2, but 0.3 centimeters. Okay. What about letter B? Okay, well, letter B, in letter B, there are smaller divisions, right? So I've got lines that are in the ones spot, and I've got lines that are in the 10th spot. So that means I'm going to estimate in the 100th spot. All right, so how many one spots does it go past? It goes past the first one, so 1. And then I go down and I look at the 10th lines. Where does it go for those? 1, 2, 3, 4, 5. Looks like it's past the 6. Okay. And so I'm going to go ahead and I'm going to put a 6 in there. And last but not least, I got to estimate. So again, I'm going to go ahead, I'm going to look. Looks to me like this thing is more than halfway in the gap. So by our rules, more than halfway, I'm going to put a 7 or an 8 there. It looks to me to be more towards the middle, so I'm going to go with a 7. But you could just as well have an 8 there. So 1.67 centimeters. All right, same thing. Next one here, question number 2. Go ahead and take your measurement and then come back and we'll talk about it. All right, so this is a graduated cylinder, and you'll notice that there's a curve on this one. It's a meniscus, and our rule is that we measure from the bottom of the curve. So let's go ahead and let's take a look at this first. I've got these lines here, okay, a 35 and a 40. That means that these lines in here must be going up in the 1 spot. So 35, 36, 37, 38, 39, 40. So that's going to be, so we know we've got something in the 10 spot, something in the 1 spot. No line smaller than that, so that means we're going to estimate in the tenths. So if I go ahead and I look here, again, we've got 35, 36, does not make it to 37. So we're going to go 36. And then I look in the gap and I say, okay, halfway, more than halfway, less than halfway. So I would put this at less than halfway. Some people might see it as halfway, but 36.3 is where I would go with that, or 2 or 5. Any of those I think would work. 36.3 milliliters. And last but not least, we have a thermometer. What's the temperature on the thermometer? Use the maximum capability of the scale. So here's 80, here's 90, so that's going up in the 10 spot. There are lines that are smaller than those, so that's in the 1 spot. So that means we're going to estimate in the tenths. Okay, so I'm going to look. It goes to 80, 81, 82, 83, 84, 85, 86, 87. And then I'm going to go ahead and I'm going to look in that gap. To me, it looks like it's almost exactly halfway in there. So I'm going to go with 87.5 degrees Celsius. And that is how you measure using a tool to its maximum capability.